Pythagorean Theorem, Day 2, using Pythagorean to find missing sides, with sometimes having perfect squares and sometimes needing to simplify the square root. Notice on this worksheet it says to give both the exact answer, which is simplifying the square root, and then to approximate. It's just typing it on in and rounding it to where it tells you. And remember, if it doesn't tell you what to do, Mr. Walls says 2, round to the nearest hundredth. For this guy, I'm going to fold this paper just like this so you can see these 17, 18, 19, and 20 and be able to write the work on the side. You're welcome just to do that on a separate piece of paper if you'd like, but we're going to zoom on in here. Take a look at number 17 again, where it says find the missing angle. Notice it is a right triangle, so you can say it's right. Everybody say right. Say right. It is a right triangle. Across from the right angle in the right triangle, we're going to label this as our hypotenuse, or hype. So number 17 then, start off with our formula for Pythagorean Theorem. A squared plus b squared equaled c squared. Most important thing is the hypotenuse. It has to go in for c. If you want to put in x, great. So it's x squared. Just want to put in c squared, that works too. And then the legs, doesn't matter which one goes where. 3 squared plus 6 squared. And then if you wanted to jump all the way down and tell me that that was 45, you can type that into the calculator, do the work, and tell me that 45 equals c squared. Or again, you could take this with mental math or one step at a time. 3 squared is 3 times 3, which gives you 9. And 6 squared is not 12, it's 36. That's where that came from. So from here, take the square root of both sides. We do that because the square root and the squared cancel. You're left with c. Cross your fingers. Did the square root of 45 come out to be nice? No, it did not. It came out to be, about 6.71, 6 and 71 hundredths of a centimeter. That's the approximate, or approximately equal to 6.71. Now, find the exact answer. That's where we're going to find the perfect squares that go into 45, where again we talk about going down that list, just like we've done before. Can 4 go into it? Can 9 go into it? 16, 25, 36, 49, so on and so forth. Finding that largest perfect square that can go in there, do that. So since that would be 9 times 6, 9 times 6, all underneath the square root. Then give them each their own square root, give them each their own little jail. The square root of 9 times the square root of 6, and the square root of 9 is 3. Oh, I did that math wrong, excuse me. I get that one wrong often. This is the square root of 5, excuse me. So this should be the square root of 5. Thought something sounded funny. 9 times 5 is 45, not 9 times 6. Again, the classic example, mental math, make a quick mistake. Happens often, even your math teacher makes mistakes. But here is the correct exact answer. 3 square root of 5. That's for number 17. Number 18, again, it's a right triangle. So, starting with Pythagorean's theorem to find a missing side length, a squared plus b squared equals c squared. Go to number 18, across from the right angle is our hypotenuse. Plug that in for our c value. So, 8 squared equals, put in your one leg and any letter you want. I'm going to put it in there for my a, so that's now 6 squared. Notice the difference between my 6 and my b. The 6 got the slant. You need to be careful on your own. So that gives me 36 plus b squared equals 64. Solve this equation. We want to get b all by itself, or rather in this case b squared all by itself. So I'm going to add a negative 36. It's the same as subtracting 36 from both sides. That leaves me with b squared equals 28. Don't want to know b squared. Want to know what number times itself gives me 28. Want to find the square root, both of them, because the square and the square root cancel. So we're left with b equals, well, now here again, type it into the calculator. Did it come out nice? Nope. Came out to be a decimal. So they said, tell me what it is approximately. So it's approximately 5 29 hundredths of a centimeter, 5.29. Round wherever you need to, but if they don't tell you what to do, Mr. Walls says 2. But now it says, do the exact. So when we look at the exact, now we're trying to find the perfect square that goes into 28. Largest one that goes into 28 would be 4. So then that's where we're going to have 4 times 7, all underneath the square root, giving them each their own separate square root. This time Mr. Wall's writing them down almost perfectly. Step ahead of myself there. 4 square root of 7. What is the square root of 4? 2. And the square root of 7 just tags along. So when you type in the square root of 28, you get a big long decimal, which will be the same decimal as 2 times the square root of 7. That's what you're looking at. Now I can see number 20 here, so let's do number 20 while it's still kind of in view. 20 is a squared plus b squared equals c squared. The most important thing is that hypotenuse. Label it. For me, I always let you write it out as hype. It's the hypotenuse. Then, whatever leg you want, put it in for A or B. I'm just going to put it in for A. So we have 10 squared, which is 100, plus, leave it as B squared, or insert a variable, whatever you or your math teacher tells you to do. Now solve this guy. Solve it by subtracting 100, or again, I'm going to say add the negative, add the opposite. So since it's a positive 100, add a negative 100 to both sides. It leaves us with b squared equals 576. Type that into your calculator, square root of both of them. So b equals, ooh, that came out nice, 24 centimeters. So you're done. That's the exact and the approximate. No extra work needed. That's how it looks. That's how it works, no matter how they're set up. So number 19, very quickly to do one more here in this video. You just set it on up. Have a right triangle. Because it is a right triangle, we can use Pythagorean Theorem. It has to be a right triangle. Everybody, say right. Across from the right angle is your hypotenuse. Even though it's funny, it's not facing the normal way, doesn't matter. Across from the right angle is the hypotenuse. So I invite you, put in x, or just put in c squared, and then they're the same number, so what is 7 squared plus 7 squared? So again, you can jump right away to tell me that that is 98, or if you want it to put down that that is 49 plus 49, you can do that. From there, perfect square, we hope. Type it into the calculator, the square root of 98. Oh, nope, does not come out nice. Comes out as 9.89949, blah, 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 blah. You can see it in your calculator. You're welcome to write it down if you need to, but rounding to the nearest hundredth, looking back one, we have to round up. So instead of being 0.89, we're going to add 1 to that. So it's 9.90, 9.99 and 90 hundredths of a centimeter. That's what it is approximately. Now, let's get the exact. So going down the list, Mr. Walls, doesn't seem like anything goes into it. Does 4 work? No. 16? No. 9? No. 25? No. Does 36 work? Typing in 98 divided by 36 came out to be a decimal. Nope, so try the next one. 49. Aha! That one does work. So we'll write out 49 times 2, all underneath the square root. So then give them each their own jail, give them each their own timeout space and a square root sign. What is the square root of 49? So 7 square root 2 centimeters is the exact answer. The most precise answer, which you want to be using if you're in Science Olympiad, or if you're in some sort of biochemistry engineering, or in NASA doing some sort of engineering like that. Otherwise, for a lot of intensive purposes, a lot of things that you and I would just use common in our life, we could just say 9.909 and 90 hundredths of a centimeter. That is using Pythagorean's theorem, solving it, whether they have perfect squares or not.